So whenever a problem is asking you to evaluate a certain limit algebraically, the first thing you need to do is to check what x is reaching gives us 0 over 0 or not. If it doesn't give you 0, you can use that value as your answer. But in this case, we're going to check because that is the first step. In this case, we substitute x by 2 in the limit, and we get square root of 16, as you can see, 12 times 12 plus 4 minus 4 over 2 minus 2, which is equal to 4 minus 4 over 2 minus 2, which is equal to 0 over 0. So that means that we need to solve this algebraically, and we cannot get our value directly from the limit. Whenever we're solving this type of problems, we need to rewrite always limit as x approaches 2. And the second thing we need to do is to look at how our equation looks like. In this case, we have 6x plus 4 minus 4 and x minus 2. And we know by a fact that whenever something is multiplying itself with another sign, with the same terms, we get the difference of squares, which is basically a squared minus b squared. So in this case, to get rid of the square root, we need to do basically that, to multiply it by its conjugate, which in this case would be 6x plus 4 over 6x plus 4 plus 4. So we rewrite limit as x approaches 2. So as we can see, we canceled the square root, so we get 6x plus 4. We take the negative sign always, and in this case square the b, which in this case is 4, so we get 16 over x minus 2, which we don't even need to multiply times 6x plus 4 plus 4. Just add it to the equation by now. So next, we need to rewrite as always limit as x approaches 2, and we solve the terms that we have on the top of the fraction, which in this case is negative 16 plus 4, which is negative 12, x minus 2 squared. Now we're just transferring those terms, we're not doing anything, we're just simplifying the top part of the fraction. So in this case, we need to factor whatever we have on top in order to cancel it with something on the bottom. So in this case, we would have limit as x approaches 2. We would get 6 minus 2. Since we took the 6, which is a multiple of 12, over x minus 2, square root of 6x plus 4 plus 4. In this case, whenever we have something that looks like this, we would commonly cancel the 2 in order to get an x. Well, that's the same thing that we're going to do here. We're going to cancel them because they're dividing by that term, and we're going to rewrite it as the following: 6 approaches 2, and we would have 6 over square root of 6x plus 4 plus 4. So the third step in this problem is, this is the result we got from the previous step, and the next step is to simply substitute the x for the value that we got for x. So in this case, there's no need to rewrite limit as x approaches 2, so we would have 6 times 2 plus 4 plus 4. As I said, there's no need to rewrite it, so we would have 6 over 6 times 2, 12, plus 4, 16, so we would have square root of 16 plus 4 equals 6 over 4 plus 4, which itself gives us 6 over 8, which simplified gives us 3 over 4. So that is our answer, but the form to write it is to rewrite limit as x approaches 2 and the whole equation, 6x plus 4 minus 4 over x minus 2 is equal to 3 over 4. As you can see in the graph, whenever we are asked the limit of x when it approaches a certain value, if we're being asked to what y value is it approximating through the right and through the left in our function. So in our function, as we can see, when x approaches 2, y is approaching 3 over 4. So therefore our answer was 3 over 4.
So to find the equation of the tangent line at the given point, which will be this function and the point will be x equals 2, it means that we need to find the slope of the tangent line at the given point, which is x equals 2. So first we will need to find the derivative of this function, and whenever we use that derivative, we need to put the function with this apostrophe, that means the prime. So we will do the power rule, and the exponents will be 2 times 2 x 2 minus 1 minus 5 times 1, because x, this has an exponent of 1, times x 1 minus 1 plus this, when it doesn't have a variable, when it is only a constant, it will automatically be 0. So if we simplify it, it will be 4x, because 2 minus 1 is 1, so 4x minus 5. So the next step is we will replace this x, but in the derivative function, to find slope. So it will be f prime of 2, 4 times 2 minus 5, that means 3. So our slope is 3, m equals 3. Now we will replace the 2, but in the original function, to find y. So it will be f of 2 equals 2 times 2 squared minus 5 times 2 plus 1. It will be 2 times 4 minus 10 plus 1. It will equal to 8 minus 10 plus 1, and this will be, that will be equal to minus 1. So now our coordinate is 2, because x equals 2, and minus 1. We know that the equation of the slope is y equals mx plus b, and we have to find b. So we're gonna use the same formula to find b. We know the value of y, which is minus 1. We know the value of m, which is 3, and the value of x was given to us, it's 2. So we're gonna isolate b. Final equation will be y equals 3x minus 7. So we can conclude that in the point 2 minus 1, in the coordinate 2 minus 1, our equation has a slope of 3 and passes through the minus 7 on the y. It's the y-intercept. We can observe from this graph that the function is a parabola, and on the point 2 minus 1, it will have a slope of 3x minus 7, which is equal to the tangent line on that point, because it will pass through the y-axis on minus 7, and it will have a rise over run of 3.
Okay, in this problem, we're giving an example of a small town that the population is increasing throughout the years. We have to find and interpret the limit of p as x approaches infinity. T is set in years. Now here we have that p, which is the population in the case of years. We have to find out how the population is going to be in x years, in this case in infinity years.
In problems like this, the first step we need to do is to take the biggest degree from the whole equation, which in this case is t squared, and divide it by the whole equation. So it will be something like this.
In this part of the problem, it is important that we note that after we have simplified all of the t's in all of the parts of the problem, we have to insert the infinites. After inserting the infinites, we can see that 8, 800, and 5 are 0.
Okay, we are ready. Now we need to divide. We have 9,200 t squared divided by t squared, so we cancel the t squared, so it remains 9,200. 800 can be divided by t2 squared because it's infinity. So in this case, it will be rewritten as 0. We have the same here, so we can cancel directly and it substitute for 1. And this is the same case as the 805 can be divided by t squared because it's a infinity squared. It's a much bigger number, so it's also rewritten as 0.
Now after simplifying, what we have left is 9,200 divided by 1, which equals to 9,200. What this means is that when the population, or x, reaches infinity, they will eventually reach a point where the population equals to 9,200. This can be because whatever reason, maybe it's a food shortage or whatever thing, but the population, when x goes to infinity, eventually will reach to 9,200, which is our final answer.